Hi, second 15 minutes. We have this function, minus 2p squared minus 10,000 minus 9,000 p cubed equals 0. We want to find the elasticity. We're given p equals 50 and q equals 4502. So I already know those, so all I have to do is find dq dp. I'm going to take dq dp of each term. dq dp, ddp of 2p squared q, minus ddp of 10,000, which is 0, minus ddp of 9,000 p cubed. Now this is the product rule where 2p squared is u and q is v. So we're going to do the first 2p squared times the derivative of q with respect to p, plus the second q times the derivative of 2p squared with respect to p, because that's a 0, and this stays like that. We cannot do this because we're trying to take a function with respect to q with p. There is no p in that function. So we have to use our implicit chain rule. So we're going to use this and get something like this for the first term. 2p squared, I'm going to take the derivative with respect to q, which we can do. Sorry. And that's of q. And then tack on the appendage dq dp. Well, that's the first time. Here, we can take the derivative of this, because it's p and a p. It's going to be 4p. That's a 0. Here, once again, we can take the derivative. We have p and p cubed. It's going to be 9,000, 3p squared. And the whole thing equals 0. So now let's clean that up a bit. Let's go up here. I can never know what do I do with that eraser now. Just put it up here all the time. I tell myself to do that, but I don't. So let's write what I have up here. I have 2p squared dq dp plus 4pq minus 3 times 9,000, so it's 27,000 p squared equals 0. I want to solve for dp dq, so I'm going to bring all these other terms to the other side. Bring those over here. I'm going to have 2p squared dq dp equals 27,000 p squared minus 4pq. Okay, let's solve for dq dp. $27,000 p squared minus 4pq divided by 2p squared. Now, what do we know about q? We had from before. Q equals, 4505? And P was equal, let's go back to the original one, because I forgot what they were. 4502, and that was 50. So in order to find dq dp, I have to substitute 27,000 50 squared minus 4 times 50 times q, 4502 over 2 times 50 squared. Okay, I'm going to calculate this. Let's see if we can do it together. 50 squared is 2,500. This is going to be a big number.
You can get rid of a 50 through there too, right?
I'm sorry?
You can get rid of a 50 to make the calculations a little easier.
I could.
Just an
Yes. There's one thing you can do, and watch, I'll show you. This is a trick. You can make 50 squared 50. And this is 4 times 50. And you can make this 2 times 50 times 50. Notice you have a 50 in this term, a 50 in here. So you can subtract 1 from there and 1 from there, making your 27,000 times 50 minus 4 times 4,502 times 2 times 50, which is 100. That simplifies the math. 27,000 gives you 135,000. 1 million. 1,350,000 minus 4,502 times 4. 1,808. And the whole thing's going to be divided by 100. So let's see what we get when we do this. Using scientific notation would be a lot easier. Okay, it's going to be...
Dr. Mirabile?
Yes.
How did you take 4 times 4,000 and get only 1,800?
Because my calculating, because I screwed up when I was calculating it. 4 times 4,502 equals 18,008. I dropped a 0.
It's always good to do a check of the order of magnitudes just to see if it makes sense to check your arithmetic.
Well, I was going to do that at the end anyway.
Oh, yeah.
Yeah, I always do that. So this gets divided by 100. And the answer becomes 13,319. Now, this was a big number here, and this was divided by 100. So we got it down. So this is dQdP, which seems like this might be the one that dominates our elasticity. Well, let's put it into our elasticity. And let's put it into our elasticity equation and see what we get here. Is minus P over Q, dQ dP is minus 50 over 4,502 times, and this is a positive, 13319, and of course, without doing this, you pretty know what you're going to get here, but okay, so times 13 divided by, you get something that doesn't make sense, so let me do this again. Okay, 50 times 13, 319 equals, that makes sense, divided by 4,502, 147.9 minus 147.9.
That makes sense.
Okay. So that's still less than 1, isn't it? Right?
Yes, Dr. Mirabile?
Yeah? What's the problem there?
No, I said yes. Yeah.
That's still less than 1, so this is inelastic also. Okay. That goes with our... So we did a number of examples of elasticity. Most of them came out to be inelastic, which is not the usual case, but it's because the way that the problems were structured. On your homework, you'll find out that a few of them will come up with an elastic, means they're highly volatile to changes in price. Okay, now we want to do is get into tax functions.
4 minutes.
Is this the second 15 minutes?
I think so.
I lost track.
Yeah, I was compressing other videos from other lectures, so I think I did too.
Okay. Now, you might remember from QBUS-110, you had marginal rates. You actually let supply equal to demand. And we figured out some functions. Now, what we have here is basically the demand and supply function. And remember, we had demand and supply functions in 100, and we set them equal to each other, and we find out the market equilibrium point. Well, here we're interested in market equilibrium, but we also want to know what the maximum tax revenue would be. So, for example, I'm given a demand function. $900 minus 2Q minus 1/2 Q squared. I'm given a supply function. P is 200 plus 10Q. How much time?
Let's see here. 2 minutes.
All right, now if you remember at market equilibrium, we would let these two equal each other and find the Q and the P at market equilibrium, where everything started to settle down. Well, here we're interested more in the tax. So, asking you a question before we leave, where would I place a tax function? I'll call this 1 and 2. In 1 or 2 and Y. Okay. How much time?
1 minute.
All right, so first of all, let's look at the two functions. One is a demand function. One is a supply function. So this is what a supplier is going to supply. Here's what you're going to demand. Now, what the government is usually interested in is in taxing those people who are supplying it to you more than you. We're not talking about income tax here. We're talking about tax on production. So what we usually do in these problems is place a tax term on the supply equation, or in the supply equation.